All right, this is just our first step for integration, and it's just simplify. So when we're looking through our integration strategies, simplify is the first thing. And so there's a few examples here on this page that we're going to look at for simplifying. So we're going to look at some conjugates, some trig identities, but first we're going to start with just performing the operations. So if you see a distribution, you distribute. So we would get the integral of x squared over x plus x squared square root of x. And then now we can just simplify these. This would end up being x, and then x squared square root of x. That's x squared, x to the 1/2. And then we just add them, so we get x to the 5/2. So plus x to the 5/2 dx, and now we can just do our straight integral. So this is equal to 1/2 x squared plus 7/2. So then we put 2/7 plus c. And there you go. What if you have a division? Well, a division, the same exact thing. We just distribute. You divide. So we go 1 to 3, and then this would be x cubed over x squared plus x squared over x squared plus x over x squared. And then we simplify. So 1 to 3 x plus 1 over x dx. And then now we can integrate. So we would have 1/2 x squared plus x plus natural log of x from 3 to 1. And then we plug it in and we're finished. So this would equal, we're going to plug in the 3 first. So 1/2 3 squared plus 3 ln of 3 minus 1/2 times 1 squared plus 1, forgot the plus in there, plus ln of 1. That's a bracket around that one. And so we end up with 3/2 squared and 1/2. Might as well just continue. So 3/2, sorry, that's 3, 9, plus 3 plus ln of 3 minus 1/2 minus 1. And then the last one is just 0, so we're going to leave it off. And so that would be 8/2 or 4 plus 2 plus ln of 3, which would be 6 plus ln of 3. So this is old hack probably for you. You've done this a lot. It's just a reminder. So it works the same way when we end up with our trig functions. So if you have tangent theta and you can multiply it, you try that. I mean, everything in this section, what we're going to be dealing with is just try this, try this, try this. So when you see these steps where it says simplify first, it's just one thing to try first. And so we go tangent squared theta plus tangent secant theta d theta. And then now we can do a quick little switch with our tangent. That's 1 minus secant, backwards, secant squared theta minus 1 plus, and then we have tangent secant. That one we just leave alone. Forgot a theta in there. And then now we just integrate. So the integral of secant squared theta, that's tangent theta, minus theta plus secant theta plus c. All right, and then the last little trick here is using a conjugate. So if you remember 1 minus cosine x, if we use a conjugate on this, we go integral. I'm going to put the dx out here, a 1, and then we go 1 minus cosine x. I'm actually going to move that dx over a little bit more. And now if we multiply top and bottom by 1 plus cosine x, it's another trick to simplify this. So this becomes 1 plus cosine x over 1 minus cosine squared x. And if you remember what that is, it's sine squared. Yep. So we get 1 plus cosine x over sine squared x dx. And then now this allows us to use what we did before, which is with that distribution. So we come up here and we get the integral of 1 over sine squared x plus cosine x over sine squared x dx. And then you should hopefully start to see this. This is cosecant squared x plus, and then this is cosine over sine. Take it slow here. Times 1 over sine x. So we end up with cosecant squared x plus cotangent x times cosecant x dx. And now we can just integrate it very quickly. So cosecant squared x becomes cotangent x, negative, and cotangent x cosecant x becomes negative cosecant x plus c. And there we have it. So these are just methods that we've tried before. It's just all put together now. So it's just simplifying first. If you can simplify, do it. So it's just distributing, more distributing, and then this one was applying the conjugate.